If a speaker's blasting music and you stand twice as far from it, why does the music get 4 times quieter? This is what we're going to be looking at today. We're going to be looking at the energy being transported by waves and the math behind it. So first of all, let's discuss energy in a vibrating particle. So imagine this is a medium like water, and as a wave passes through, like I discussed in the last video, waves, it's just a pattern. It doesn't move the actual particles forward. As the wave passes through, each particle oscillates in simple harmonic motion. So the energy per particle can be given with this mechanical energy formula that we looked at in an earlier video. It's also on the cheat sheet in the description. But what this tells us is that the energy in the system is proportional to the amplitude squared. They're tied. It scales with the amplitude squared. So the more violent the shake, the more stored energy. For example, when there's a big wave coming on the beach, when there's a big wave coming from the beach on the water, for example, when you're at the beach and the giant wave's coming, it's a big wave, but it doesn't just look bigger. The energy is bigger. It hits way harder because energy scales explosively with size. The second thing we need to talk about is this unit called intensity. Intensity is power divided by area. Intensity in English is how much energy hits every square meter. And the unit is given in watts per meter squared. For example, the brightness of a flashlight, intensity. The loudness of a speaker. And intensity drops with distance. For spherical waves, a wave that travels in a sphere shape, what would that look like? This is your sphere. This is where the wave is coming from, the source. And it travels in this sphere pattern out in all directions at once. The intensity drops with the distance, and it doesn't drop linearly. It is actually inversely proportional to the distance squared. What does that mean? This is the inverse square law, and it applies to things like Earth's gravity, light. So that means if there's 2 times the distance, then the intensity is 1/4 as strong. If the distance is 3, then the intensity is 1/9. If we increase it by 1 more to 4, then intensity is 1/16. Inverse square law, it's inversely proportional to the square of the radius. So it drops off hard. Let's run this through an example. And I recommend you download the free cheat sheet in the description because there's a lot of formulas we'll be using. It's an earthquake signal drop-off problem, and a seismic station reads the intensity of the earthquake, to label intensity 1, equals 1.2 times 10 to the power of 6 watts per meter squared. And this is when it's 150 kilometers away. How about when we are 450 kilometers away from the center of the earthquake? What's the intensity? What does our seismic station read? So there's a special formula that comes from the inverse square law. And you may have seen this in gravitational problems. But our new intensity, which is our intensity at 450 kilometers, is equal to the original intensity multiplied by the old radius, so 150, over the new radius, so 450, squared. This is 1.2 times 10 to the power 6 times 150 over 450 squared. And our new intensity is roughly 1.33 times 10 to the power 5 watts per meter squared. It's 1 order of magnitude smaller. It went from the power of 6 to the power of 5. It dropped off hard. It's inverse square law. So as the distance increases, the same amount of energy is spread thinner over a bigger area. And we're assuming it moves like a sphere. So it drops rapidly the further it travels, even in solid rock. Here's a bonus connection. The intensity is actually connected to amplitude. It's proportional to amplitude squared. That means amplitude, and by the way, if you don't know what amplitude is, it's the maximum height of a wave. Amplitude is proportional to 1 over radius, or distance. And this comes from the inverse square law. So when you double the distance, the amplitude halves. That's why sound fades before it hits your ears. This makes studying 10 times easier. Go download the free cheat sheet in the description, and I'll include a free surprise worksheet from my premium study kit to help you understand this topic.